Hi guys, hopefully you have your notebooks out. Please open up to your table of contents and write down topic 20. Should be on page 37. Pythagorean theorem with quadratics. And pages 38, 39, topics number 21, the exact equation of a parabola. Go ahead and pause the video so you guys have time to write that down. Okay, so hopefully we've copied that down. And go ahead and open up to your page 37 and title it Pythagorean theorem. Okay. And just remember the basics. You guys know what it means for a right triangle. A, B, and C are your side lengths. C is the hypotenuse opposite the right angle, and it's a squared plus b squared equals c squared. It allows us to solve for the side of a triangle if we're given two side lengths. So we're just going to look at 3 examples real quick. There's going to be a little more difficult maybe than you've seen before, so we'll try a tricky one. Okay, so we have this side length is x. We have 2 root 3 and 5. So go ahead and copy that picture down. And it's really important that you determine which one is your hypotenuse. It's always going to be opposite that right angle. So here's my hypotenuse. It doesn't matter the other 2 side lengths. They can be A and B interchangeably. So we're going to set it up as a squared plus b squared equals c squared. Now the tricky one on this is multiplying this out with radicals. Remember, this means to multiply 2 root 3 times itself. So it helps to write this out because a lot of mistakes can occur. When we multiply something like this, we can just multiply the whole numbers, 2 times 2, which is 4. And remember, root 3 times root 3 is square root 9, which is 3. Remember, it just undoes that radical. So you should not have a radical in your answer. So 4 times 3, that whole thing goes to 12. Okay, so we have x squared plus 12 equals 25. Okay, so take your time writing that out. That's where the mistakes occur. After that, we're going to subtract 12. We get x squared equals 13. Undo your square by square rooting. And remember, usually when we square root both sides of an equation, we put a plus minus root 13. But in this instance, a negative doesn't make sense because we're talking about the length of a triangle. So we get to not put our plus minus in this answer. Will only be our positive value, positive square root 13. Okay, so your second example will be something you did see in integrated 1, but we'll refresh your memory before going on to a hard one. This length is x. This one's 14 and x plus 9 up there. All right. So remember, very important to look opposite the right angle, locate where your hypotenuse is. Set up your equation. We'll write x squared plus 14 squared equals x plus 9 squared. Okay, give you a minute to catch up. All right, now the big mistake on this, you guys, is multiplying this out. Remember, this is, and I'm going to put this up here, not equal to x squared plus 81. Okay, you can't just square each of these because there's that little addition sign in between there. So remember, what this means is x plus 9 times itself. Okay, so we're either going to have to distribute that, multiply it out, or box method, whichever you prefer. But regardless, on this side, after multiplying it out, you know, you can do your box if you feel like it. Some of you can do this in your head. This is what we're doing. If you don't have to show this, that's awesome. You get x squared, 9x, 81. So you multiply this out, we get x squared plus 18x plus 81. Remember, that's not the same as x squared plus 81. On this side, we're going to have x squared plus 14 times 14 is times 14 is 196. And you got this equation in integrated 1, which nicely, these x squareds canceled. You go, oh, okay, those go away. And we're left with 196 equals 18x plus 81. And to solve for x, we can subtract 81 from both sides. And we get 115 on this side equals 18x. Divide by 18, it's some ugly decimal. So we can just leave our answer as 115 over 8. That is completely fine. Or you can compute that into a decimal. Okay. Now the only difference with today's lesson is this is an integrated 1 type problem because these x squareds nicely canceled. And so you had what was a linear type of an equation. Well, today, now that you guys know how to solve quadratics, you won't have those x squareds cancel. So you get to do some integrated 2 stuff. All right, so let's look at our third problem. This is the big one. And this is what you'll see on your test this Friday. Okay, so draw one more triangle. Okay, label those sides, x, x plus 3, and x plus 6. And remember to locate where that hypotenuse is. Very important. That guy's my hypotenuse. And write your equation. X squared plus x plus 3 squared equals x plus 6 squared. And remember, this is not x squared plus 9. We're going to write this out twice. Okay, write this guy out twice, x plus 6, x plus 6. And remember to box that out if you need to, or distribute, however you prefer. So we should get here x squared plus 6x plus 9. And after multiplying this out, x squared plus 12x plus 36. And you guys, don't worry if you can't multiply these guys out in your head. Just write out the boxes like I did on the previous problem. Okay, after you do enough of those, or in higher math classes, you can kind of do those real quickly. But that's what I'm doing, just multiplying these guys out. Okay. Now notice I have 2x squareds over here and only 1x squared here. So one of these guys is going to cancel, but I'm left with an x squared. So right when you see that and you know it's going to be quadratic, move everything to the left side of the equation, set it equal to 0. Okay. So I'm going to minus 12x. So I'll have x squared minus 6x. And I'm going to minus 36 over this side, which will give me negative 27. Okay. And usually these will factor, but if they don't, you can use the quadratic formula. And actually, I think on your classwork, some factor, some don't. And if they don't, you have to use the quadratic formula. This one nicely factors to minus 9 plus 3, which means I'm going to have two solutions. X equals 9 and negative 3. But you have to stop and think on this problem. This is kind of weird. These refer to answers that are related to some type of length in a triangle. So you have to go back and make sure both of these answers make sense. 9 does work, but notice when I plug in negative 3 here, I can't have a negative length for a triangle. So negative 3 gives me what's called an extraneous solution. Okay, so we have to cross this one out. And my only answer is x plus 9. So I'm going to tell you what that word is, extraneous solution. These occur in a lot of kind of upper division math type problems. When you're solving an equation, you do everything right. We solved it correctly, but for whatever reason, you need to go back and check, and this actually is an extra solution that doesn't make sense in the context of the problem. So you have to omit it, cross it off. Okay, so that's it for the notes. If I went too fast, hopefully these paused for you, and I hope that makes sense, and I will be back soon. You guys can start your worksheet and help each other out, and good luck, and I'll see you soon.